Myself Nagarajan, Assistant Professor in Department of ECE. Today we will see about the digital signature under the topic of networks and security. So after completion of this course, the digital signature, and completion of this course, the student will be able to explain the digital signature. So digital signatures, the basic definition of a digital signature is a public key primitives of message authentication. So digital signatures are a public key primitives of message authentication. Digital signature is a technique that binds a person entity to the digital data. This binding can be independently verified by receiver as well as any third party. So digital signature is a cryptographic value that is calculated from the data and a secret key known only by the signer. The receiver of the message needs assurance that the message belongs to the sender, and he should not be able to replicate the origination of that message. This requirement is very crucial in business applications since likelihood of a dispute over exchange data is very high. So digital signature is a public primitive of message authentication. This is a message authentication. So bind a entity of a digital data. This is a model of a digital signature. In the signer side, we have a data. It's included with a hashing function. Hash function it is given to a signature algorithm, and we have using a separate private key for signer, and is given to a data signature for a verifier. If the hashing functions are equal, and then verification algorithm is used to by using the same public key. Each person adopting this scheme has a public private key pair. Generally, the key pairs used for encryption, decryption, and signing verifying are different. The private key used for signing is referred to as the signature key and the public key as a verification key. Signer feeds data to the hash function and generates hash of a data. Hash value and signature key are then fed to the signature algorithm, which produces the digital signature on given hash. Signature is appended to the data and then both are sent to the verifier. Verifier feeds the digital signature and the verification key into the verification algorithm. The verification algorithm gives some value as a output. Verifiers also runs the same hash function on received data to generate a hash value. For verification, this hash value and the output of verification algorithm are compared. Based upon the comparison result, verifier decide whether the digital signature is valued. So digital signature is created by private key of signer and no one else can have this key. The signer cannot repeat signing the data in future. It should be noticed that instead of signing data directly by signing algorithm, usually a hash of data is created. Since the hash of data is a unique representation of data, it is sufficient to the hash in place of data. The most important reason of using hash instead of data is directly for signing is the efficiency of the scheme. So as discussed in the public key encryption character chapter, the encryption signing process using RSA involves modular exploitation. Now digital signature message and the authentication. When the verifier validates the digital signature using the public key of a sender, he is assured that the signature has been created only by sender who possesses the corresponding secret private key and no one else. Data integrity. In case an attacker has access to the data and modifies it, the digital signature verification at the receiver end files the hash of the modified data and the output provided by the verification algorithm will not match. Hence, receiver can safely deny the message assuming that data integrity has been breached. Non-repudiation. Since it is assumed that only the signer has the knowledge of the signature key, he can only create unique signature on a given data. Thus, the receiver can present data on the digital signature to a third party as evidence if any dispute arises in future. So encryption with the digital signature. In many digital communication, it is desirable to exchange an encrypted message than plain text to achieve confidentially. In public key encryption keys, a public key of sender is available in open domain, and hence anyone can be spoofed of identity and send any encrypted message to the receiver. This makes it is essential for user employing public key cryptography for encryption to seek digital signature along with the encrypted data to be assured of message authentication and non-repudiation. This can achieved by combining digital signature with encryption schemes. Let us briefly discuss how to achieve this requirement. There are two possibilities: sign then encrypt and encrypt then sign. The crypto system based on sign then encrypt can be exploited by receiver to spoof the identity of sender and send the data to third party. So hence this method is not preferred. This is a sign then crypto. Data is given to encryption using prior receiver public key hashing function. It is compared the two key and encrypted data and digital signature. So I hope that all of you understood about the digital signature of the networks and security. Dear student, thank you.